let's discuss binding energy curve. Here, binding energy per nucleon is shown on y-axis and mass number on x-axis. If we observe carefully the graphs, we will find that binding energy of deuterium 1H2 is less than 2 MeV, whereas that of tritium is more than 2 MeV. In case of helium, it is more than 6 MeV, but that of lithium is less than 6. Carbon has binding energy around 7.3 MeV, whereas nitrogen has around 7 MeV. Then oxygen has binding energy more than 8 MeV, and Fe has highest binding energy around 8.7 MeV. Then it decreases gradually, and finally for W it comes out to be 8 MeV, then it decreases. Uranium, whose atomic mass is 238, has binding energy less than 8 MeV. That is why it undergoes fission reaction. Due to fission, it will break up into two smaller nuclei whose binding energy will lie in the range here to here, means more than 8 MeV. So the reason for fission and fusion is that in case of fission, the heavier nucleus breaks into two daughter nuclei whose binding energy per nucleon increases, and they become more stable. The same is case of nuclear fusion, in which two smaller nuclei having less binding energy per nucleon combine to form a bigger nucleus whose binding energy per nucleon will be more. For example, suppose we take 1H2 plus 1H2, and we get 2He4. So if we observe carefully, 1H2 has binding energy less than 2 MeV, but that of 2He4, it is more than 6 MeV. So this is the reason why fusion reaction takes place. Similarly, when uranium undergoes fission, it breaks into barium and krypton, whose atomic mass lies in the range 50 to 200. So their binding energy per nucleon will be more. Hence, they will be more stable. Thank you for watching.